Oh, yes. When I found out that Google was doing career certificates and they had one in data analytics, I thought it seems like an easy choice. After completing the program, I was familiar with all the tools of the trade and all the real world applications. I worked a lot of jobs. They weren't anything I was passionate about. And I'm able to do data analytics now as my full-time job. And I'm happy.
Put your skills to work with a Google Career Certificate.
Hi, everyone. Welcome to this workshop, Explore Advanced Data Analytics Skills and Careers. I'm Sushila. I'm a data scientist at Google. I'm also the instructor that will guide you through the videos in the 6th course of the Google Advanced Data Analytics Certificate. I am excited that you've joined us today. In this workshop, we're going to explore the world of advanced data analytics. The workshop is designed for anyone who's interested in developing advanced data analytics skills and exploring a career as a data professional. If you'd like to gain foundational skills in data analytics, or if you're new to the field, we encourage you to start with the Google Data Analytics Certificate. This advanced workshop builds on existing data analytics skills and experience to take your career to the next level. We're excited to hear from you, and we have a team ready to respond today. If you have any questions as you watch this workshop, please submit them in the chat section so we can answer them. Today, we're going to talk about advanced data analytics and data science. You'll learn how data roles have become increasingly important for businesses. We'll start with an overview, covering what data science is, who advanced data professionals are, and the current demand for careers in the advanced data analytics and data science space. Then, we'll go through a typical workflow for a data analytics project called the PACE framework. PACE stands for Plan, Analyze, Construct, and Execute. We'll follow this framework as we try out a real-world data analytics scenario using Python. Finally, we'll explore how you can start on your advanced data analytics career, as well as what to expect from the Google Advanced Data Analytics Certificate. Let's get started by discussing what advanced data analytics is and how the demand for these jobs continues to grow across many industries. Advanced data analytics is a field of study that falls under the larger discipline of data science. Data science is aimed at making data more useful. It produces broad insights that concentrate on which questions should be asked about the data, and it confronts the unknown by using advanced techniques to make predictions about the future. Since data is the foundation for making future decisions, businesses rely on data professionals to analyze data, extract value from it, visualize it, and communicate their findings to key stakeholders. The insights that data analysts produce help companies make sound, data-driven business decisions, such as the best ways to improve operational efficiency, marketing, or employee retention. Now that you know a little more about data science, let's try a short activity to engage your analytical thinking skills. In this activity, you're a senior data analyst for a professional basketball team. It's your responsibility to help management identify which players to recruit for the upcoming season. To do this, you need to predict a player's future performance based on past and current data. But metrics and findings from past player performance data may not always predict how they will perform in the future. So you need to analyze the reliability of past performance to determine future performance. And you need to examine which particular features of past performance are most predictive of future performance. Given these challenges, what kinds of data would you collect and analyze to best determine which players to recruit? You can pause the video and take a few minutes to write down your ideas. This activity is just to get your juices flowing. Feel free to leave your answers in the chat section before we move on. You're already thinking like a data scientist. Now, let's explore how you can use these skills as a data professional. Data professionals are individuals who work with data to provide insights. They often use advanced analytical skills such as data manipulation, experimental design, predictive modeling, and machine learning to find insights from the data and make predictions about the future. You'll learn some of these skills in this workshop and on the job. Many data professionals have gained these skills through their education, experience, or training. And you can grow these skills by completing the Google Advanced Data Analytics Certificate. And these professionals can fill a variety of roles that use these advanced analytical skills, like senior data analysts, junior data scientists, or data science analysts, among other job titles. Some of these more advanced skills might be new to you, like machine learning. Machine learning focuses on the use of data and algorithms to imitate the way that humans learn. Through the use of statistical methods, algorithms are trained to make predictions and to uncover key insights. These insights drive decision-making within businesses. For example, let's say you're a data professional for a global hotel chain. The company has conducted a customer survey about the layout, colors, and graphics for all of their hotel websites and found that customers responded negatively to all of the images with insects. Instead of trying to manually locate each image that contains an insect across all of the numerous international hotel websites, you, as the data professional, can write an algorithm and train it to detect images of insects. Then, you can run your algorithm so it can identify all of these images across all of the hotel chain websites. Once identified, you or the hotel chain's computer programmer can go through and remove each of the flagged images. Don't worry if you aren't familiar with machine learning yet. You can learn more during Course 6 of the Google Advanced Data Analytics Certificate. Companies need data professionals to use data to refine their business strategies, meet customer preferences, react to emerging trends, and predict future business decisions. This is great news because it means that careers in data science are in demand. In fact, there are more than 144,000 job openings in the advanced data analytics field. Now, let's explore a typical project workflow for a data professional using the PACE framework. Most data professionals follow some organizational framework as they work. It helps to keep them focused on the impactful actions in the most efficient order. It also makes collaborating with colleagues more effective, as other team members or departments might be responsible for different tasks within the project. One example of an organizational framework is the PACE model, shown on this slide. This framework can give you structure while allowing for flexibility when working on projects. The PACE framework can help you think and organize a project like a data professional. And it's the framework you'll use in the Google Advanced Data Analytics Certificate. PACE stands for Plan, Analyze, Construct, and Execute. We'll cover each part of the PACE framework, but depending on the project, a data professional might not be involved in every step. First, in the plan stage, you define the scope of your project. To start, identify your company's needs. To do this, you should ask yourself questions like, does this project align with the organization's business goals? What problem or problems am I trying to solve? What do I need to do to make sure I collect the right data? In order to answer these questions, you might schedule meetings with the stakeholders to determine the expected project outcome, learn what data sources are needed and how they can be accessed, as well as who the audience is for the project findings. For example, will you deliver your results to the marketing or finance team, or will you be presenting to the CEO of the company? Let's try out a scenario using PACE, starting with the plan stage. Have you ever used a rideshare service before? You might have used one before to get to the airport, to go to a sporting event, or to meet up with friends at a restaurant. What if you could work for a rideshare company to help improve the service for riders like yourself? In this scenario, you'll do exactly that. You get to be a data professional working for a global rideshare company. Your new project is to determine the days during the week that experience the highest volume of rides, as well as the average distance of travel for each ride. With this information, drivers for the rideshare company will be able to plan out the best shifts to work throughout the week. For this type of project, the plan stage is critical. You need to ask the right types of questions to collect the right data because the drivers may base working hours on your results. For example, if you only plan to gather data on days and times that experience the highest number of ride requests, you might miss important data on duration of travel. You also want your data to be able to answer questions like, How many ride requests are a mile or less? Will it be better for some drivers to drive fewer riders for longer durations or more riders on shorter trips? These types of questions are helpful to ask as you plan. What kinds of questions would you ask in order to plan for this project? You can pause the video and take a few minutes to answer. The next stage is analyze. During the analyze stage, you gather the necessary data from primary and secondary sources, clean it, reorganize it, and analyze it. You also engage in exploratory data analysis, or EDA. This analysis involves converting your data into usable formats like charts, maps, and graphs, as well as assessing the ability of your data to meet your goals from the plan stage. Exploratory data analysis is important because it helps you to better understand and validate your data before making statistical assumptions. When examining your data, there are different types of challenges you might encounter. These include missing data, false data, or bad data, like data that has been duplicated, among others. These issues can impact a data professional's ability to analyze the data. To resolve these problems, data professionals clean the data. Cleaning the data might involve deleting blank cells of data or unifying mixed data types, like cells containing numbers and text, into a single type. For example, let's say you're a data professional at a fashion rental service company. The company collects data about the styles customers prefer and the prices they're willing to pay. This data will help the design team to create items their customers will love and will rent. In order to do this, the design team needs you to analyze datasets of customer preferences and pricing. In their survey, customers were supposed to enter numerical data, ranking items on a scale of 1 to 10, and typing the number in whole dollar amounts that they would be willing to spend on the item. But when you import the data into a spreadsheet, you get data that contains cells with text, like the number 5 written out, blank cells, and cells in which customers used the $ symbol. In order to get accurate results for the design team, you'll need to clean this data. Now that you've learned more about the analyze stage with our fashion rental company example, let's revisit the PACE scenario in which you're a data professional working for a global rideshare company. Once you answer all of the questions needed to plan for your project, you focus on collecting the data you need and analyzing it. While most data is stored in databases, data can sometimes be collected and inputted into spreadsheets, like in the section of the rideshare data spreadsheet on this slide. Depending on the project, you might have thousands of rows of data, which would be a challenge to analyze with just spreadsheet tools. Instead, you might use online notebooks like Jupyter or Collaboratory, or Colab for short. This slide shows what data analysis in Colab looks like. These digital notebooks allow anyone to write and execute Python code through a browser. Python is one of the most popular programming languages for working with data because it can be used to perform a wide variety of data-related tasks. You can use Python to create websites, automate tasks, and analyze data, and data professionals often use it for machine learning. Jupyter and Colab are great workspaces for practicing coding in Python. You can even share your workspace with others or upload your work to other online notebooks. For our PACE scenario, we imported a spreadsheet with a dataset into Colab to analyze the data. Let's take you through the steps of our analysis. In this slide, you can see what a Colab notebook might look like. It contains text cells that you can type in to explain your analysis, as well as code cells where you input Python code. You can see that we already covered the first step of listing the types of questions you might ask before starting your analysis. As we mentioned, the next step in the framework is to analyze the data. To do this, we had to import pandas and other code packages, which are listed on the bottom of the slide. Code packages are data analysis libraries that are built on top of the Python programming language. Pandas is an open source library for Python. You use pandas for data analysis and manipulation. When you import code packages, you have access to multiple libraries of code to help you analyze your data. For example, Matplotlib is a data visualization and graphical plotting library. When you want to create a bar or line chart or even an animated visualization, you can use Matplotlib. Next, we load the spreadsheet of data into Colab. As a data professional, you want to see how your data is structured and make sure it's the right type of data before diving too deeply into your analysis. We can input a line of code and run it to check out the first 10 rows of our dataset. In this case, our line of code is df.head, open parentheses, the number 10, and close parentheses. The slide shows this code and the first 10 rows of the dataset. The DF stands for data frame. A data frame is a type of data structure similar to the spreadsheet we loaded into Colab. The 10 in parentheses stands for the number of rows the code returns from the data frame when we run it. You can easily change how many rows you view by adjusting the number in parentheses. Now, we can check out the first 10 rows of data. In our scenario, we know the data had been cleaned before we accessed it. We can see that it has columns for rider ID number, the distance traveled in miles, rounded to the nearest mile, how long each ride was in minutes, and the date and time that the pickup took place on. Next, let's learn more about the dataset by examining the correlation between the distance traveled and the duration of the ride. The slide shows the code we use to get the average minutes of the ride duration for each distance of travel. For example, riders who took trips that were 3 miles long spent on average 7.23 minutes in the vehicle to get to their destination. Now, take a minute to review the overall output shown at the bottom of the slide. What do you notice? The data provides you with logical results, meaning that the shorter the distance traveled, the shorter the average duration of the ride. And as the travel distance increases, so does the average ride duration. However, as a data professional, you'll encounter numerical results that are not clear or easy to understand. In these instances, you might create visualizations like charts or graphs to better understand the stories in the data, like the one shown on the slide. Data professionals often conduct analyses for colleagues in other departments, key stakeholders, or potential investors who don't have a background in data and need an explanation of the findings. By converting the results into a chart or other visualization, you can make the information more accessible to those outside of the field of data analytics. To create a bar chart, we use code that plots the distance traveled on the horizontal axis with the average ride duration on the vertical axis. The bar chart is also color-coded to make it easier for someone to interpret the results. Take a minute to reflect on the distance traveled and ride duration results we just reviewed, and ask yourself, was it easier for you to understand the findings in a numerical format or in a graph? And which format do you prefer? Feel free to pause the video and take a few minutes to answer these questions. Next, to uncover more findings from this dataset, we write a line of code to reformat the information from the dataset to be machine readable. For example, the date of each ride request needs to be in the same numeric format as the other data, and currently, the date is not formatted as a number. These changes need to be made so the Pandas library can read and work with the data. Otherwise, we couldn't use Pandas to continue to analyze the data. Then, because we're interested in understanding the busiest times during the week, we use the dates to find their associated day of the week. So September 23rd would change to Friday, for example. To do this, we write a line of code to add columns to our data frame containing the text names and assign a number value for each day of the week. For example, 0 equals Monday, 1 equals Tuesday, 2 equals Wednesday, 3 equals Thursday, 4 equals Friday, 5 equals Saturday, and 6 equals Sunday. Now that all of the data is in the same readable format, we write a line of code to create a table of information from the dataset. Creating a table will help us understand the story the data is trying to communicate. Take a few minutes to review the information that's visible in the table on the slide. The table shows the distance of travel requested for each day of the week. For example, on Mondays, riders only requested trips that were 3 miles or fewer. The table also shows the count, which is how many riders took trips that were 1 mile, 2 miles, 3 miles, 4 miles, or 5 miles. You'll notice that on Fridays, the distance of travel that had the highest number of riders was 4-mile trips. And in the last column, the table shows the mean, which is the average ride duration in minutes. If you look at Wednesday, for riders who took trips that were 2 miles, the average driving time for the ride was 7.1 minutes. Sometimes a visualization makes it easier for data professionals to draw conclusions about the data. And if a data professional is delivering their findings to the marketing team, a visualization like a graph or chart might make the results more accessible and easier to understand. Let's take the data from the table and write a line of code to create a scatter plot matrix, which is also referred to as a pair plot. A scatter plot matrix is a quick way to visually represent relationships among 3 or more variables in a dataset, like distance traveled, ride duration, and days of the week. This type of visualization creates 2 pairs of charts. One of those pairs are density plots. Let's take a closer look at one of the density plots on this slide. As you look, to the right of the density plot shows you the color codes for the distance of travel. Blue equals 1 mile, orange equals 2 miles, green equals 3 miles, red equals 4 miles, and purple equals 5 miles. And in this density plot, the numbers on the horizontal axis refer to the days of the week. So 0 equals Monday, 1 equals Tuesday, 2 equals Wednesday, 3 equals Thursday, 4 equals Friday, 5 equals Saturday, and 6 equals Sunday. From the visualization, it shows that Saturday and Sunday are the only 2 days out of the week riders requested trips that were 5 miles. To help you find this result, remember the color purple represents 5 miles. Once you've finished analyzing the data, you might move on to the next stage in PACE, construct. In this stage, you build, interpret, and revise machine learning models and algorithms. A machine learning model is a computer program used to discover patterns in data or to make predictions. This information helps to uncover relationships within your data and helps you unlock insights from those relationships. Based on your data and your goal, you might use one of several models, including linear regression, which is a model used to predict the value of a variable based on the value of another variable or variables. A data professional might build a linear regression model to predict the effect of increased advertising on product sales. Or decision trees, which are graphs that use a branching method to illustrate every possible output for a specific input. Visually, it looks like a flowchart. A data professional might build a decision tree to predict the cost of rideshare fares based on weather conditions and trip data. Another type of model is naive Bayes, which is an algorithm that's useful for making predictions and forecasting data. For example, a data professional for an electric company might use naive Bayes to predict possible future outages. To make these predictions, they would use millions of data points from equipment like transistors, circuits, meters, smart meters, and electrical poles. They might examine historical data, like the last time a pole was inspected or when it was put into the ground, to determine the poles most at risk of failure, which could cause power outages. You might not build these types of models for this rideshare analysis, but these are ones data professionals commonly use. The final stage of PACE is execute. If you're involved in this stage as a data professional, this is when you get to share the story you've uncovered from the data. You'll present your findings to internal or external stakeholders like managers or investors, answer questions, and consider different viewpoints. This is also when you present your recommendations based on the findings in the data. Findings might be presented as a written report, tables, graphs and charts, or a combination of these. To communicate their findings and recommendations, data professionals might deliver a presentation using an online tool like Google Slides, develop a PDF to email stakeholders, or share the dashboard they created using Tableau or a similar visualization program. In their recommendations, data professionals might include their reasoning, referencing their data, and consider opposing viewpoints to their recommendations. Now it's your turn. Think about the findings from our analysis of the rideshare data. Consider one shift you would recommend to drivers who want the lowest number of riders but the longest distance of travel, or for drivers who want the highest volume of riders but the shortest distance of travel. You might have several recommendations, but for this scenario, you'll just make one. Check out the Colab practice project if you'd like to review the analysis one more time. You can find a link to the Colab practice project in the description of this video. You can pause the video to share your recommendation in the chat. Great work, everyone! You just experienced a data analysis project. Hopefully, this process has helped you better understand what a typical project workflow might be like for a data professional. If you're interested in advancing in your data analytics career, or you recently completed the Google Data Analytics Certificate and are exploring career paths, the Google Advanced Data Analytics Certificate might be a great fit for you. In the Google Advanced Data Analytics Certificate, you'll learn how to create data visualizations and apply statistical methods to investigate data, how to build regression and machine learning models to analyze and interpret data, and how to communicate insights from data analysis to stakeholders. Some of the tools you'll use in this program include Jupyter Notebook, Kaggle, Python, and Tableau. With these kinds of advanced analytical skills in your professional toolkit, you'll be able to explore a range of career opportunities in the field of data science. For example, if you're interested in roles that are more technically focused, you could consider a future as a junior data scientist or a data science analyst. With a focus on mathematics, statistics, and computing, you would use data to build models and make predictions. Using programming languages like R or Python, you would help your team extract value from business data sets in order to make the most informed and accurate data-driven decisions. Though we've focused on Python thus far, R is another programming language used for statistical computing and design. Data professionals often use R for data importing, cleaning, and visualization. Or, if you're interested in roles that are more strategic, you could consider a future as a senior data analyst. Your work might involve interpreting information that impacts a company's operations, finance, or research and development. Your aim would be to align with the overall business strategy and to use data analytics to help solve business problems. Completing this certificate will help you prepare for job opportunities in the advanced data analytics career path. Google has teamed up with a consortium of companies that will consider hiring you as a certificate graduate in a variety of fields, including e-commerce, healthcare, manufacturing, marketing, finance, or tech. Upon completion of the certificate, you can directly apply for jobs with over 150 US employers, including Google, Salesforce, Adobe, and Verizon. These companies are ready to consider Google Career Certificate graduates and often post openings to an exclusive job platform that you also get access to. The Google Advanced Data Analytics Certificate program has a lot to offer to help you on your path to a new career. The program has a low monthly cost and financial aid is available. It's fast and flexible. The certificate program is online and self-paced. You also get to learn from Google experts who work in the fields of advanced data analytics and data science, like me. I'll be your instructor while you complete course 6 of the certificate program. All of the content is developed and taught by Google employees who work in the field. After completion of the Google Advanced Data Analytics Certificate, you'll be able to take the skills you learned, like advanced data analysis and modeling techniques, and lead data-driven decision-making processes in the workplace. Graduates also have access to job search resources like access to staffing firms, Big Interview, an online job interview training program, and Interview Warmup, a tool that helps graduates practice and prepare for their next interview. And the Advanced Data Analytics Certificate program will help learners stay competitive in the job market and their workplace. The portfolio projects enable learners to build tangible artifacts that can be used to demonstrate advanced analytical skills to employers. Learners can provide these examples during job interviews or in discussions about advancement opportunities. Let's hear some testimonials from folks who have earned their credentials from Google Career Certificate programs. The learners who have taken Google's career certificates have had great results so far. One learner, Johanna, said, "The instructional videos in the Google Advanced Data Analytics Certificate were well-paced and easy to follow. I really enjoyed the instructors, particularly Cassie. Her optimism towards data is infectious." Kwame said, The Google Advanced Data Analytics Certificate has the statistics course for beginner data analysts or scientists. It also has great refresher materials for people who may already be familiar with data science. It covers the fundamentals of statistics and gives a lot of context to the critical phases of the data analytics process. And Derek said, I really enjoyed learning how to better communicate with others at my organization. The Google Advanced Analytics Certificate provided really beneficial frameworks, like the PACE model, for organizing my workflow. Google also offers career certificates to help you find a job in other in-demand fields. You can prepare for a new career in under 6 months part-time. Google career certificates are available for data analytics, business intelligence, advanced data analytics, digital marketing and e-commerce, IT support, IT automation with Python, project management, and user experience design. Get started at grow.google/certificates. Let's take a moment to recap what you learned and share resources you might find useful. Today, you took the first steps in learning how to pursue a future in advanced data analytics. You explored the foundations of data science. You learned about each stage of the PACE framework for keeping you organized and on track when you complete a data science project. And you followed several steps within the framework, including asking essential questions about the data you need to analyze, entering Python code into a Colab notebook to analyze a dataset, creating a visualization in Colab to examine the data, and making recommendations based on your findings. You also learned more about the Google Advanced Data Analytics Certificate. If you enjoy video lessons, subscribe to the Grow with Google YouTube channel at youtube.com/growwithgoogle. We want your feedback. Please share your thoughts by visiting g.co/grow/feedback or by scanning the QR code on this slide. Thank you so much for joining us today. Good luck in pursuing your new career.